Hello and welcome to Trailblazers. This is a series of conversations with Columbia University faculty whose ideas shape our world. I'm your host, Dustin Foote, and today we're talking about the research of pandemic preparedness with Professor Stephen Morse. Professor Morse is a professor of epidemiology at Columbia University's Mailman School of Public Health and one of the country's leading experts on emerging viruses and infectious diseases. He has spent decades studying how viruses jump from animals to humans and what it takes to stop outbreaks before they spread. From global pandemics to preparedness and prevention, his work sits at the intersection of science, policy, and public health. Today, we're talking to Stephen Morse about his work and what emerging viruses reveal about how outbreaks begin, along with his lessons from COVID-19 and how we can be better prepared for what comes next. Professor Stephen Morse, welcome to Trailblazers.
Thank you. It's a pleasure to be here.
I wanted to start at the beginning. What drew you to epidemiology in the first place?
Well, actually, I started out working in the lab, and I was trained as a virologist and viral immunologist, and thought I would spend my entire life as a lab rat. And in fact, I was working in the lab at Rockefeller University when I became interested in the question of what I called emerging viruses, and that was sparked by a seemingly innocent question from our then president, Joshua Lederberg. And as I became interested in this question of emerging viruses and organized with my colleagues at National Institutes of Health a meeting on this in 1989, people were very uncertain about where new virus and new virus infections and new infections in general that seem to burst upon us with great suddenness and sometimes great force, like HIV, for example, where they came from. And it seemed a mysterious thing. Of course, now it isn't. I think we understand so much more about it. But I also decided at that time, I was working in the lab doing work on virology and T-cell relationships, the effect of some viruses on T-cell development. But as I became more and more curious about emerging infections and where they were coming from, it also occurred to me that if I really had the courage of my convictions, I should go where it might be possible to do something about it. And it struck me that was public health, that public health had the capability to be able to prevent the emergence of new infections and their spread.
What was it about emerging viruses that sparked your attention at a time where it seemed like nobody else was looking?
Well, I think I like mystery, and this seemed like a mysterious question. Where were these infections coming from? Why were they happening? And of course, in retrospect, the answers are perhaps not as abstract, although there's still a lot to learn. But at the time, it was quite a mystery. And one of the things in my own field was that there were some people, most virologists, in fact, most microbiologists, believe that these infections that seem to appear suddenly and unexpectedly and perhaps with new features were the result of rapid evolution of viruses or other microbes. And we always concentrated our efforts there, but that's really hard to define. We really can't predict evolution at this point very well. So as long as it seemed such a mysterious problem linked to the evolution of these microbes, it seemed an insoluble problem. In retrospect, it turned out that there are answers. We do understand where these infections are coming from, and they're not from outer space. They're not the Andromeda strain. They're not the result of something that's newly come into being as a result of a lot of mutations, although that does happen and obviously plays a role both before and after a new infection or a new to us infection may emerge. But they come from within inner space, if you will, from other species and so on our own planet. But at the time, it seemed that with the Andromeda strain and the mysterious appearance and spread of HIV, all of this seems so dark and unexplainable. And that's what fascinated me about it. I just thought it was a really interesting question, and I like mysteries. So,
can you talk about zoonotic infections and why they pose such a threat to human health?
So zoonotic infections these are infections that spread under some real-world conditions from other species, usually other vertebrate species, to humans. And those turn out to be at the root of many of these emerging infections simply because there are so many, such a great biodiversity of infections in other species, some of which have the potential to infect humans, and some of which may get the opportunity to spread. People have tried to map what we might call hotspots of these emerging infectious diseases, and that was something that some of my colleagues at EcoHealth, and I was involved in that also. But what usually turns out to be the common factor is these are areas, the hotspots are areas of biodiversity. So you have a lot of different pathogens that might be out there in other species that also have an interface with humans. People are now encroaching in these areas in various ways, whether it's through mining or lumber cutting of forests or through agriculture. All of these various things provide the opportunity for humans to come in contact with these once hidden, if you will, sequestered deep in the forest, infections in other species. And so the hotspot maps usually show that the places with the greatest biodiversity and the greatest interfaces with human beings, especially those undergoing the most change, often in tropical areas of the world, for example, are usually where we might first expect to see these infections emerge. And then, of course, there's the question of how do they get from there to somewhere else if they're going to get our attention and get our notice.
Well, how do they jump from one thing to another?
Well, once they jump from one species to another, let's say into the human species, and of course there's so a lot to be learned there, then, I think the difficulty for these infections is really, first, they have to be able to reproduce themselves within the human body. So in some way, they have to replicate. And our immune systems, our various mechanisms of host defense prevent many of these infections from ever gaining a foothold. But in addition to that, there's a very important characteristic. They have to have some way, once they can grow or replicate, reproduce themselves inside the human body, they also have to have a way to transmit to other people, to other hosts. And that's why many of these have natural hosts that are in other species. They're zoonotic because their natural hosts maintain these infections in nature, something like Ebola in bats, for example. Certain bats, which we think are the natural host for the Ebola viruses. They then obviously often may kill too quickly, or not have the opportunity, or not spread efficiently, and so they're not able, as in the case of Ebola, they can be very dramatic, but they don't spread very far in most cases, simply because they're not highly transmissible. But other conditions may make it possible, closeness in cities, for example. But on the other hand, if they can't transmit, an infection is probably not going to go anywhere. And so that's really one of the hardest things for an infection to be successful. Now, sometimes it can do this naturally, the way influenza does, the way, many other infections we know about. Smallpox, which is really was an exclusively human infection as it evolved in humans, or measles, similarly, through the respiratory or touch routes by skin contact. But also, There can be the blood supply or other practices by human beings that may allow infection to be transmitted, or within a hospital setting, for example, through those lapses in infection control. But transmissibility and transmission is really, I think, the most difficult part for us to predict, and also for a new infection to get off the ground.
I wanted to ask you about your work bridging the gap between academia and government. What makes this work so important to you? And also, what makes it so important to all of us Americans?
The ultimate goal really, initially was to understand how these infections were emerging. I think we have a much better idea, and to be able to spot them in the early stages. So we would call that early warning, and being able to identify where an infection is circulating is what we generally call public health surveillance, and not to be confused with other types of surveillance that have been in the news much more. But that's really essential, because if you don't know where something is, or you don't know it's there, then you really can't act effectively. And one of the things, therefore, that's very important is being able to develop the capabilities to identify what's out there, to find things that are spreading or that have the potential to move or may belong to a class of bad actors, like the influenza viruses, the coronaviruses, and some of the others that we know have the potential to cause major epidemics. Worldwide epidemics, essentially, that cover much of the world, are called pandemics. And we're, of course, frightened of the 1918 influenza pandemic, which may have killed 50 million people or more, many of them young and healthy adults. And it was probably the greatest natural disaster in terms of numbers in history. And of course, we had the 14th century Black Death, the plague, which had a tremendous demographic impact, but we didn't have the tools at the time to understand what was causing it and how it was spreading. Now we do. We have a number of mechanisms by which we can look for these infections out there in nature and find them perhaps when they first infect humans, at least come to medical or some kind of public attention, sometimes even through the press. And if you want to stop it in its early stages, that's obviously the place where you have the greatest opportunity to prevent an infection from becoming a pandemic, as we just saw. So we're still learning how to do that, but it's important to bridge the government, which in many ways, it carries out these functions and has the ability to carry out this function, because much of public health is just that. It's public, and it's carried out by various government agencies, sometimes at the local level, but then, often with assistance or cooperation and coordination from higher levels, the national or internationally, the World Health Organization. So that early warning surveillance is really important. And then I think one of the places where we really haven't understood how to deal with it is how to use that information effectively. So after the 1989 National Institutes of Health meeting on emerging viruses, there was a question, how do you follow up on this? And we thought that the World Health Organization, had this as one of their core responsibilities, global surveillance of infectious diseases. But it turned out that World Health Organization in many ways is a wonderful organization. It's the best we've got, and we'd like to see it obviously improve. It's the only game in town that has the effectiveness and the reach to do what it can do, just like CDC in the United States, which has contributed a lot of expertise there. But they didn't see it at that time, because of the leadership at WHO, as a core mission to do surveillance or early warning, or even really looking at the global distribution and spread of infectious diseases. And so we started something called the Program for Monitoring Emerging Diseases, ProMed, and the idea was really to develop a network of scientists and laboratories around the world. We had about 60 of them all over the world who were members of this network, to be able to identify unusual occurrences of infectious diseases and either try to identify the cause or work with other facilities, other laboratories, for example, in the network, to try to find whether that pathogen could be identified by some more advanced methods, perhaps, or more specialized laboratories, and also to share information. The idea was really to link these places that might be seeing something unusual, link the knowledge and capability to identify these things and to share this information. And in fact, Ian Lipkin contributed information on some of the West Nile events and offered to share reagents, diagnostic tools with people who might be seeing this virus for the first time, although it had been seen in many other places before. So that's taken on a life of its own, and now there are a number of other similar systems that, using today's technology, are able to give better early warning, but we still have a need to integrate this more. And PREDICT was able to lay some of the groundwork. ProMed was able to lay some of the groundwork. But I think what needs to be done now is really to think about, what is the next step to try to stop these infections early on?
Yeah. So in your mind, what are the biggest strengths and weaknesses in today's early warning systems?
There are many gaps in our early warning systems because all of them, are essentially voluntary. And in recent years, the availability of electronic information, and in fact, many parts of the world that were once very remote now have mobile phone, cell phone coverage, I think has improved that. But one of the things that's needed is some way to integrate this information. There have been many attempts to do this, but they still often reside in separate streams of information which are not brought together and evaluated. And then to think, how are you going to act on this information? So there are gaps in identification and reporting all along the line. And then once something is identified and reported, as we saw with this last pandemic of SARS coronavirus 2, the virus that causes the COVID-19 pandemic, there hasn't really been political will or resources to think about what to do next to stop this before it got beyond the point of being stopped, essentially, and you now had to rely on the medical system, which was very heavily overburdened, or on eventually vaccines, which have been a great help there. And we saw a similar thing with the outbreaks, and there are several now of different varieties of Mpox, formerly monkeypox, in a number of places. And that should have been a no-brainer because we have been thinking about the possibility of smallpox through either accidents or terrorist attacks ever since smallpox was eradicated around 1980, and we no longer vaccinate the entire population. In fact, very few people are now vaccinated for smallpox because it's no longer necessary. So we've been worried about this ever since 1980 and working hard on how you deal with it and how you contain it. And then something so closely related comes along and sweeps through the world, which I think is an indication of how unprepared we are. So we need political will as well as the technology. I think the technology is incomparable today. It needs to be more, pushed out more, but it also needs to be taken more seriously and used more effectively.
Let's talk about COVID. Talk to me about what life was like for you here in Columbia, New York City at that time, and what do you think you learned from that whole experience?
Yeah, that was, personally a very difficult experience, I have to admit, because, I've worked for a number of years, a number of us have worked for, 20 or 30 years on trying to develop better early warning systems and prevent the next pandemic. And it so happens that I was called upon quite a lot to consult on precautions here at the university, how we could make the workplaces safer. I chair our institutional biosafety committee. We're working round the clock in many cases. We were meeting several times a day, of course, on Zoom. But, to try to develop and talk to the investigators and others working here, developed the mechanisms and the procedures so that people could work here safely and have a safe workplace. That took quite a lot of effort. And then seeing this going on all around me, I teach a course, which I've taught since 2001, called Emerging Infectious Diseases. So we've gone through a number of pandemics, but there was nothing more surreal than teaching a course about potential pandemics and other emerging infections and how to recognize them and stop them when there's a pandemic all around you and you have to teach the course remotely because it's not safe for people to meet in classrooms. That was a surreal experience, and I think it encapsulated the kind of surreal feelings we all had, especially those of us working in this area, and the exhaustion that it caused, not just, of course, terrible exhaustion to the medical community and the medical facilities because they were just overtaxed with all the patients. So that changed our way of life, and it was really painful to watch, personally, after spending years trying to prevent just this sort of thing from happening. We should have known better.
What do you think you learned, if anything, from the local and national community in the years that have followed since this pandemic?
I think we still have a long way to go in terms of educating not only the policymakers, but making sure that our leaders, really understand what's at stake and that their words have consequences. Truthfully, I think that the health department likes to point to examples, post 9/11, for example, when the leadership, the political leadership, would actually get advice from the subject matter experts, if you will, the health departments or emergency responders, and then transmit that advice, and other trusted sources would tell people, what was the best scientific knowledge at the time. Always imperfect, always evolving, but we recognize that and we say that up front. And now we've seen a situation where, unfortunately, I hope our leadership will learn to do that, but we've seen several years continuing on now, where there's been, essentially two messages, and unfortunately some of the messages that I think are not helpful to preventing or to containing infectious diseases are coming from political leadership. And I think they have to understand the consequences. Now, we have to do our job, obviously, to inform the leadership, also to inform the general public. But, obviously, it should not be a political issue. It should never have been a political issue. There are lives at stake. And the viruses do not distinguish what party you belong to, what state you live in, what your political views are. They're more interested in your biological characteristics and whether you are able to get infected.
Mm-hmm. Now, the same leaders, politicians, scientists even, are already talking about the next pandemic, or at least so I've heard. How do you think about the next pandemic and our preparedness, your life's work, for the next emerging virus?
Well, the whole reason, actually, that I developed and invented, if you will, this concept of emerging viruses and emerging infections later, was basically to not get complacent about these things. It's not always going to be the known and expected, but very often the unknown and unexpected, and we have to be prepared for that. Obviously, we want to be able to identify the known and expected and control those, but that should be a given. We should be able to do that, and even there we have some gaps. But the unknown and unexpected, HIV was a total surprise in many ways, and I think reminded us that infectious diseases would not always follow the rules that we might have imagined we laid down for them. Influenza has shown many possibilities in the past of causing pandemics, some devastating. And so that's one that obviously we always keep our eye on. Since SARS of 2003, the first coronavirus outbreak in humans, there's been a lot of interest in coronaviruses, and we know many of them are out there. So we should have been better prepared. We've had, this is the third coronavirus outbreak that, essentially has crossed internationally in 3 decades. SARS, severe acute respiratory syndrome in 2003, Middle East respiratory syndrome, another coronavirus, slightly different branch of the family tree, about 2012, and then in this decade, SARS coronavirus 2, the COVID-19. So I think we really, complacency worries me a lot, but I think also it's important for us not only to educate the policymakers and the people who are going to help to provide the leadership and political messages so as to depoliticize these issues and provide the resources, because these are very under-resourced areas, but also for all of us to become better informed, because there are things we can do. And so we have an obligation, I think, to go out and make sure that people are well informed.
All right, so we like to end these episodes on a light note. So with that in mind, here is my final question for you. What is a piece of pop culture, a movie, a TV show, or a novel that actually gets something right about your field or hilariously wrong?
I can give a few examples. They are getting better. And I do have to admit that, although the movie Contagion of a few years ago, some people thought that it seemed almost too much like a documentary. Although, interestingly enough, the latter stages obviously had to be imagined because we'd never really had, events like that. But they probably rang true, and the science certainly rang true, in part because of a lot of input and a brilliant script writer, Scott Burns, but a lot of input from people like Ian and Lipkin and others. So I think they tried to get it right. The irony of that, something we thought about, was that it ended when a vaccine became available. And one thing we have learned from this last pandemic is it's not enough to have a vaccine available. People have to be able and want to take it. So, vaccination, not just a vaccine. But, we all naively thought that once we had a vaccine, we could, end a pandemic. On the other hand, that was a film that got things pretty much right in many other aspects. Most of the films on this subject, most pop culture on this subject that I'm aware of, have been quite good. But the more fictionalized ones usually are way off. They try to make disaster movies. So, not to call out any specific examples, but Outbreak, for example, was way off course. And we all found it embarrassing in many ways that most of these films and most of these pieces of pop culture take sort of the same tack. They try to fit themselves into being the disaster movie. And even though they may be disasters, they're different, and they have to be regarded on their own terms. We have to take them that way. On the other hand, since this pandemic, people have become better educated, and I suspect probably some of the cultural offerings have become more accurate as well.
Great. Well, Professor Stephen Morse, thank you so much for joining us.
It's my pleasure. Thank you for your time. Thank you for asking me.
Trailblazers is a production of Columbia University's Office of Public Affairs. You can listen to our other conversations on Columbia's Impact and Innovation website, our Vimeo page, or our YouTube channel. Thanks so much for listening.